All right, and we are live. Welcome everybody on into tonight's live. I am Robert, the AP Math Guy, and tonight we're going to be talking about how to sketch different graphs of f of x using calculus as our guide. So, as we jump on in, please be sure to hit that like button. Let's see if we can't get to 500 likes before we get started. So while you do that, I'm going to go ahead and say hi to press the button that allows me to wave at certain people. But if you can't, or if I can't press that button for you, I'm going to go ahead and say hi to you anyway. Hi, everyone. So tonight, hopefully everyone's had a good Tuesday evening and a good Tuesday overall. I know I have. Oh, here's my water. Very important. If you're ever live, it is very important to keep a bottle of water. Or even a glass of water, or whatever, however you want to have water. And I don't know about you, but when I talk for a while, my throat gets kind of dry. So I need the water. So yeah, last night we hit 2,000 followers, and I am really appreciative of you all for helping me hit that. Oh, we're already at 500 likes. Perfect. Thank you, Mark. How's it going? But yeah, no, I'm really thankful for everyone that helped me get to 2,000 followers, and I'm thankful for you all because you're going to help me get to 3K likes and then 4K likes. Let's try again. Well, you're going to help me get to those number of likes too, but 3,000 followers and then 4,000 followers, and then who knows, by the end of the year, because of you all, I might get to 5,000 followers. At the beginning of the year, I said my goal was to get to 1,000, and we're far past that. I agree. I agree with you 100%, Mark. One at a time, right? Yeah. Welcome on in, everyone. But my Tuesday's gone pretty well. Um, yeah. So while we're getting ready to get started, I want to point out that tonight, so I decided to do this one, this one in two parts. So tonight we're going to be talking about sketching different graphs of f of x. Tomorrow we're going to be looking at sketching derivative graphs. Or we might get into it a little bit tonight. Depends on um, where we are. But I at least want to sketch some graphs of functions tonight. And then so we actually after this, we only have optimization. We actually only have a couple more topics to go before we're done Calc 1. Am I on the West Coast? Nope, I'm on the East Coast. I am on the East Coast. So it is 11:30 here on the East Coast, which means by the time this live is going to be done, it's going to be October. At least for me. And most likely are if you're in the central time zone of the US, then it's probably going to be October for you as well by the end of your life of this live. But um, if you're in Europe or anything on the other side of anything on the other side of the Atlantic Ocean, then yeah, it's already October for you. And I'm in Hawaii, not for me. Fair enough. It will be in a few hours though. What is it? 5? It's like what? Almost like 20 to 6 for you. When am I doing integration? I was just about to get there, Miki. So we have this topic. So we have this tonight and tomorrow, and then we have a couple more topics in Calc 1. We're going to be doing optimization for a couple days, and then we'll be doing we'll be looking at actually, I think that's it. So plan is to start Calculus 2, I think sometime next week. So that's when I'm going to start doing integration. I haven't decided what I want to do. I don't think it's going to take me all week to get through this and optimization. But so I'm trying to figure out, but I want to wait until next week to start Calc 2. So I'm trying to think of different things to do. I might, you know what? I have a whole list of topics that I have to get through. Maybe I'll get through some of the ones that require only algebra, that don't require calculus too. So I might go absolute value sometime this week. I might do factoring trinomials. I think I'll do. Do you know stats? I do. Stats is actually going to be coming up in a little while because I am doing, starting next week, as well as starting Calculus 2, I'm also starting a brand new live. So, to that, I had, so as of right now, and this is subject to change between now and next week, but if it does change, I will let you know. So I have two, this is my brand new live schedule starting next week. So I'm going to have 2 lives every day. The first live is going to be 2 o'clock p.m. and it's going to cover everything from algebra to pre-calculus. I might throw stats into that live as well. And then the second live, which is going to be moved back from 11:30 to 10 p.m. Eastern, is going to cover everything from calculus on up. So again, this starts next week. For now, all of my lives are going to be at 11:30. And actually, it's funny that so I think I know how I want to spend that third one. Or I might do someone asked me for annuity problems, so I might do those as well. I don't know yet. We'll cross that bridge when we get there. Have I talked about derivatives? Yes. Yeah, yes, I have. And in fact, we're going to be talking about some more tonight. But if you want to find those past lives, you can go here, and this channel is where you're going to find them. But of course, do this stay for this first and then go back and watch my past lives. I respect. How do I get motivated to do math? So honestly, I'm not a motivational coach. My big thing is that math is not meant to be something that's done quickly and like I have to rush and get this problem done. I have to memorize all this. No, it's real. I like to think of math as like doing a puzzle, right? It's a good way for us to grow our minds and open our minds, because our brain, just like our brain is a muscle too, and we have, in order to keep it strong, we have to work it out, and math is a really good workout for your brain, or at least so I think. Um, Really, the thing as far as getting motivated to do math, I think first we have to break that mental barrier, if there is one, of, well, where am I going to use this in my life, or um, I this is too hard, because really math is everywhere, right? Math is all around us, whether we realize it or not. That's irrelevant. Um, so I'll be honest with you. I've been working over the last year to lose weight, and sometimes I don't really feel motivated to to go out and do what I need to do to lose that weight. Um, but I realize that um, I have to do it anyway. So really, I also think it comes down to knowing your why. Why why do you want to do math? Is it so that you can pass a test? Is it so that you can get into a college? Or is it just because you want to exercise your mind? All three of those are perfectly valid motivations. But the thing is that um, when we find that motivation and we find that why, it's a lot easier for us to do that thing. I respect the night streams. Impressive you're able to maintain the energy this late. Yeah, I'm honestly, Josh, I'm still trying to figure out how I'm able to do that. Um, but the reason I'm moving them back an hour and a half is because I'm finding that my sleep schedule is not doing the best. So um to fix that, I'm moving my schedule back so that way I can get to bed earlier in the evening. But I'll still be on. And who knows? Maybe by moving it back, I'll have even more energy. Thank you, CC Milla, for the follow. Thank you so much. All right, so I've wasted enough time. Let's go ahead and get started. Hey, Imperfect, how's it going? Welcome on in. So, let's talk about how to sketch a graph. So, in calculus, one of the things that calculus allows us to do is to graph relatively accurate graphs of different functions. So we all know, or maybe we don't all know, but um, suppose I have a function like y equals mx plus b. What would that graph look like? What do you think? What would that graph look like? Angel says a line. Body says linear. Imperfect says, I'm going to assume you meant linear, very imperfect. Yeah. So this would be a line. What can you tell me about this line? What are some what how would you describe this line? Or what are some characteristics of this line that tell me it's a line? That's right, B is our y-intercept. Is there any other defining feature? Okay, Angel, that's okay. There's one more defining feature of this equation. So this is our y-intercept. Y-intercept. What do they call this type of line? Not necessarily. Because that point might not even be on the... Yes! There's a slope. Where's the slope? That's right. That is absolutely right. So, the characteristics of this line is that it gives us a slope and it gives us a y-intercept. Awesome. So we know... Oh, you said that? I must have missed it. Let me check. Hey, Brainsy, how's it going? So yeah, our slope is m, and our y-intercept is b. So those are the two characteristics that we can use to draw this line. Now, what if I told you that no matter what function we choose, there are characteristics to it that can help us draw the function. So that is what we're going to be doing tonight. We're going to be talking about how to sketch different graphs of f of x. And we're not going to be doing linear functions because we already know how to do those. Or, for the most part, I think we already know how to do those. But if not, that's okay too. I'm talking about functions that are nonlinear. So, when we talk about sketching a graph in calculus, we can do it. We first have to know some defining characteristics. So, what are our characteristics? So we need to know the following. A, we should probably find our x and y intercepts if there are any. So, x and y intercepts. We need to know where slope is positive, negative, or 0. We need to know where the concavity is positive, negative, or 0. And we also need to know what's going on at the end, how a function is behaving at the end, at positive and negative infinity. That looks like negative x. Where's negative x? Here? Oh, this one. X and y intercepts. Yeah, so that's supposed to be a dash. If you want, I can get rid of that dash. There we go. No more dash. So if we know these four things, we can graph the function, or at least try to, or have a more accurate depiction of the graph. Now, I'm going to be honest, this is the part of VLive where I'm going to give you the warning. I can't draw very well. So I apologize in advance if you have to, for having to be subjected to my awful drawings. So, to help with that, we're gonna be doing all the manipulation on this paper, and then I have some graph paper for us to actually draw the graphs. So we're gonna be switching from this pad to this pad from time to time tonight. So just know that. Thank you, Flame, for the follow. And thank you, Ali, for sharing the live. So let's start by looking at our first function. So let's take a look. If m hashtag 0 I'm not quite sure what you mean by that. So, why do I sound like Leonard from the Big Bang Theory? Trust me, I'm not trying to. I could sound like Sheldon if you wanted me to. Although I have to admit, I don't do a very good impression. He speaks a little higher than I do. So, let's take a look at a function. And like I said, I can't draw, so please forgive me for what drawings you're about to see. So, let's take a look at our first example. Let's say I have f of x, or y, equals x cubed minus 12x. So, first thing I want to know is the following. So, I want to find the x and y intercepts. So, first, let's find the x-intercepts. So, to find the x-intercepts, so x-intercepts are found when y is equal to 0. So, let's take a note of that. So, to find the x-intercepts, I need to set this function equal to 0. So, I have 0 is equal to x cubed minus 12x. So, let's start by figuring out how to factor this. So first, what do you think I should do first? What should we do first here? Yeah, Mukhtar, that's exactly right. I can factor out an x here, and I can factor out an x here. So I have 0 is equal to x times x cubed divided by x is x squared. And negative 12x divided by x gives me minus 12. So now that I have that, I factor out an x, but I'm not done factoring because I still have this x squared minus 12. So here, I'm going to use this thing called difference of squares. And I know it's hard. I know it's hard to see, but I'm going to pretend for a moment that 12 is a square. So let's remember what difference of squares says. So remember, x squared minus a squared is equal to x plus a, or the quantity x plus a times the quantity x minus a. So here, remembering that rule, I have 0 equals x times the following. So 12, so I have an x here and an x here. I have a plus here or a minus here. And it doesn't matter which sign goes with which one, right? Or does it matter whether I put plus first or minus first and plus first? What do you think? Mukhtar says doesn't matter. Shane says does not matter. Thank you, Falcon, for the follow. Yeah, so it does not matter. Why? Because in multiplication, let's say this were 3 and this were 2. 2 times 3 is the same as 3 times 2 because in a multiplication, order doesn't matter. So whether I have a plus here or a minus here, or a minus here and a plus here, that doesn't matter. All that matters is the number that goes with that. So thank you, Schwab Motor Company, for the follow. So here, what's the square root of 12? And no, don't give me a if you could, don't give me a yeah, so I could write it as 2 root 3, but for now, let's just write it as root 12. But you're absolutely right. I could simplify that to 2 root 3. You're absolutely right. Why aren't there thousands watching this? That's a good question. I don't know. But what I do know is that they're missing out. So here, I can now, because I can't factor this anymore, I can now use the zero product property. And what does the zero product property say? Well, zero product property says that when I'm multiplying, either this is going to be 0, or this will be 0, or this will be 0. So either x equals 0, or x plus this 2 root 3 equals 0, or x minus 2 root 3 is equal to 0. If x equals 0, well, that just speaks for itself. So x would equal 0. If x plus 2 root 3 is equal to 0, then x would equal minus 2 root 3. Why? Because I can subtract 2 root 3 to both sides, or x equals 2 root 3. Yeah, that's exactly right. Or 0 and plus or minus root 12. That's right. Thank you, Brentley, for sharing the live. Math scares people. And you know what? That's fair. I'm not gonna. So, I think the issue, though, with that is that when we learned math, sometimes I'll kid you not, sometimes I had teachers that did this. Today, class, we're gonna talk about we're gonna talk about math, and I'm going to just sit here and try and talk like this the entire time because I'm gonna make sure that you're bored in math, and it's gonna get to the point where um you'll hate math because of how I taught it, and I hate math, so I'm gonna force you to hate math as well. And the thing is that I actually did have teachers who did sound like that, especially the worst time was like eight. It was like first block of high school at like 7:30 in the morning because I'm tired, and if I have a teacher that's talking like that, it's going to be pretty easy to sleep in their class. Although those are always the teachers that are have a who are always watching, so it's really kind of difficult to sleep in their class. Do I do any derivatives? I do, and in fact, we're about to do some here in a moment, Shane. Are you good with discrete math? I'm struggling. Any tips? I haven't taken a formal discrete math class before. Um, hmm. Well, I'm gonna tell you my big thing about any math class. The big thing is to make sure that you're taking really good notes and that you're asking questions if you don't understand something. Um, but I can't say I have any specific discrete math tips because I haven't taken a formal discrete math class before. But I've wanted to, like you, Mukhtar. I've wanted to take a discrete math class, so you have to let me know how it is. So let's go ahead and talk about how to find the y intercepts. So we found the x-intercept, so that's going to be really important when it comes to our graph. So now let's find the y-intercept. So y-intercepts are found when x equals 0. So here, to find the y-intercept, I plug in 0 everywhere I see an x. So I have y is equal to 0 cubed minus 12 times 0. If that's the case, then what must y equal? Thank you, Bones, for sharing the live. Thank you, Tim Dung, for the follow. For sharing the live twice. Imperfect says 0. You should make playlists in your TikTok account with it. That's actually not a bad idea, Roberto. I haven't thought about that. I might actually do that. That's actually a good idea. Thank you, Chris, for the follow. I'm still learning a lot about TikTok, so I have to figure out how to do something like that. But I'm sure it's pretty simple. But yeah. Yeah, so when we have problems with our math problems, fair enough. I will go ahead and look into that, Roberto. Like that, that's actually not a bad idea. Hi, Caden. How's it going? So yeah, so I agree with you, Imperfect. So 0 cubed is 0. Negative 12 times 0 is 0. 0 minus 0 is 0. So our y-intercept is going to be at the origin. So in fact, one of my roots is going to be the origin. Do you have any videos on exponential growth or decay for pre-calc? I don't. But I am working on a series of videos right now, and I'll go ahead and add that to the list. Actually, if I don't already, I'll actually add that to their topic request list. So, do I have it already? Let me check. Checking. Don't see it. No, not there. Not there. Okay. I've actually wanted to do an exponential growth and decay. Growth and decay. Alright, it has been added to the list. Hey Hippo, how's it going? Is that a PERT formula? So, I just learned this. Oh, wow. Perfect timing, I guess, then, Hippo. Graf-Stokes theorem, please. Or Green's theorem. So tonight, I'm just going to focus on graphing the problems that I have prepped. But I might do those. I think I'm gonna do those later. Is that a PERT formula? Exponential growth is, especially when we're talking about compound interest. Do you do first order differential equations? I do. But we're gonna do that a little later. Do you have your degree in pure math, sir? Nope. I just have a bachelor's in math. We didn't differentiate between pure and applied. Am I fried if I don't take Calc 3 before college? No. I didn't. I took one calculus class before college. Do you only do live tutor for calc? Nope. In fact, I'm going to be doing a second live here soon, focusing on things before calculus. Well, that's what I'm doing right now. That's exactly what I'm doing now. So we now know our x and y coordinate, or our x and y intercepts. So we have that off our list. So now we're going to do, we need to find where the slope is positive, negative, or 0. So for that, derivative tells the story of the slope. So we need, if we want to know where the slope is positive, negative, or 0, we're just going to take the derivative. So I took the TSIA 2 math. Could you do lives for that? I actually don't know what that is. I do not know what that test is. We just did trig sub for Calc 2 in class today. Could you do a practice problem by chance? So tonight, I just want to focus on sketching different graphs of f of x, but I do have trig sub on my list. So I will probably be getting into that. I'm not sure when, but it'll be probably in about a couple weeks. So let's go ahead and take the derivative of this function. What would be the derivative? Or if I'm going to use y, I should stay consistent. So dy dx is equal to what? Imperfect says 3x squared minus 12. Hey, Jacob, how's it going? You say 3x squared minus 12. 47 says 3x squared minus 12. Josh says 3x squared minus 12. Right. That's exactly right. So why is that? It's because we are using power rule. And for those of you who are new, how do I find derivative of what's the power rule? Well, the power rule says if I have x raised to any power, I take that, move it out front, and multiply by whatever coefficient's in front, and then subtract by the exponent by 1. So here, I take my 3, move it out front, so that's 3x, and 3 minus 1 is 2, so 2 is my new exponent. And then remember, a variable without an exponent is the same as that variable raised to the first. So I take my 1, multiply by negative 12, so that's going to be minus 12. X to the 1 minus 1 is 0. And remember that x to the 0 is equal to 1. So there is my derivative. Now, I need to find where the derivative is positive, negative, or 0. So let's start by finding where it's 0. Hi, can you show us the full paper of the rules, please? As soon as I'm done with this problem, as soon as I'm done with this particular graph, I would be happy to show you the derivative rules. Just remind me as soon as I'm done, because if you don't, I'm going to forget. So here, I'm going to set this derivative equal to 0. So 0 is equal to 3x squared minus 12. So I can factor out a 3 in this, right? Because 3 divided by 3 is 3 goes into 3, and 3 goes into 12. So I have 0 equals 3 times x squared minus 4. Yeah, so because 3 can never equal 0, I'm just going to divide that out. So we can say bye to that 3. So I have 0 equals x squared minus 4, which, if we remember, it's another difference of squares. So I have, let me write a 0 first, actually. So 0 is equal x here plus minus there. What's the square root of 4? Thank you, Fedamine, for the follow. Right. X plus 2, x minus 2. That's right. Thank you, Abram, for the follow. So now, either x plus 2 is equal to 0, or x minus 2 is equal to 0. So either That's true, or that is true. Thank you, TBH, for the follow. So if x plus 2 equals 0, then x equals negative 2. And if x minus 2 is equal to 0, then x must equal 2. So this is where my critical points are going to be. This is where the slope is going to equal 0. Thank you, Nicholas, for the follow. So now let's find where our graph or our slope is positive or negative. So I'm going to bring out my number line. I'm going to plug in negative 2 here, and I'm going to plug in 2 there. So now, go ahead. Let's pick so I'm going to pick a number less than negative 2, and I'm going to plug it into my derivative. Remember that it doesn't matter what the answer is. All I care about is what the sign is, whether it's positive or negative. So, thank you, Nicholas, for the heart me. So go ahead and pick a number less than negative 2. What do you want me to use? Negative 10? Okay. Negative 10 works. So I'm going to do it up here. So 3 times negative 10 all squared minus 12. Is it just me or is the screen a little blurry? That's much better, I think. So here, negative 10 squared is 100. Negative 10 all squared, rather, is 100. 3 times 100 is 300. 300 minus 12 is positive 288. And the last time I checked, positive 288 is positive. So I'm going to put a positive here. That tells me from negative infinity to negative 2, my slope is going to be positive. Thank you, Gene B, for the follow. So now, let's pick a number between negative 2 and 2. May I recommend 0? All right, 0 it is. So I have 3 times 0 squared minus 12. 0 squared is 0. 0 times 3 is 0. 0 minus 12 gives me negative 12. And I believe that number is negative. So I'm going to put a negative here. So that tells me that from negative 2 to 2, my slope is going to decrease. But what does that also tell me about 2? Is that a maximum or a minimum? What do you think? Is negative 2 a max or a min? Jason says max. Imperfect says max. Nightstar says max. Natalie says max. Yeah, this is a max. And then, let's pick a number greater than 2. How is anti-differentiation? Starting that tomorrow. So, anti-differentiation, you're doing the derivative, but in reverse. So just know, if you're good with your derivative rules, normally they're going to start you off with like reverse power rule, but just know there are different tools that we're going to use to do anti-differentiation. All right, so 10, 55, and 3, all of them are going to work. I'm going to go ahead and pick the first number I got, which was 10. So I'm going to do 3 times 10 squared minus 12. So 10 squared is 100. 3 times 100 is 300. Minus 12 is 288. Now, 288 is positive. So that means from 2 to infinity, my slope's going to be positive. That means, what would 2 be? Is that going to be a maximum or a minimum? Nightstar says men. Imperfect says max. Are you trying to say minimum, Nightstar? Nick says min. Yeah. So it's a minimum. So this is a minimum. So a maximum occurs when I go from a positive slope to a negative slope, and a minimum occurs when I go from a negative slope to a positive slope. So think of it like this. If I'm so I start by climbing up a hill, or climbing up a hill, and then at -2 I'm at the peak of the hill. So then I have to go back down into the valley. So I go down the hill until I reach the valley, which is at 2, and then I start climbing the hill again. So positive slope, positive to negative is the peak, and negative to positive slope is the valley. Hey, excuse me, can I go to the bathroom? Yeah, go ahead. You don't need to ask. Thank you, Karopi, for the follow. Do you cover Calc 2? Yep. In fact, I'm going to be starting Calculus 2 next week, Nick. I really doubt that all this is easier than a table of values and connecting dots. And I mean, if you do want to use a table of values, then go for it. I'm just showing you how I would do it. Thank you, Sarah Veza, for the follow, and thank you, Nick, for the follow. So, now we have found where our slope is positive, negative, or 0. So I'm going to put a check mark right there. Now, I need to find out where the concavity is positive, negative, or 0. So in order to do that, I have to take the derivative of my derivative. So go ahead and take the derivative of 3x squared minus 12. What would that give me? Accurate says 6x. Imperfect says 6x. Yeah, that's exactly right. So here I use power rule again. So I take my 2, move it out front, and multiply it by 3. So that's going to be 6. X there, 2 minus 1. Well, 2 minus 1 is 1. And remember, a variable without an exponent is the same as that variable raised to the first. And then so here, there's no variable next to that 12, so that is a constant. So the derivative of a constant is equal to 0. So rather than write minus 0, I'm just going to not write anything there. So now, from here, I need to figure out where my concavity is 0. So 0 is equal to 6x. If that's true, thank you, Imran, for the follow. If that's true, then what must x equal? Thank you, Kyler, for the follow. So the origin is two numbers imperfect. I only want 1. Thank you, Kyler, for the rose. What's a tangent line? So the tangent line is a line that touches the function at one point. Is tangent line the derivative of a symmetrical line? I'm not sure. Thank you, H, for the follow. Jose says 1 over 6. Not quite. Remember, I'm trying to find 6 times what equals 0. Imperfect says 0. Yeah, That's exactly right. So 6 times 0 equals 0, so x must be 0. So this is called a point of inflection. What that means is that at the origin, my function is going to change its concavity. So concavity, remember, is which way the function faces. So let's draw our number line again. I'm going to put 0 right there. Thank you, Kyler, for another rose. So now, let's go ahead and pick a number less than 0. Excuse me, I have math exam for GED next week. Is this help me? -1? Okay. So I don't, last time I checked, I don't think calculus ever appears on the GED. I want to be a math tutor at my college. Any tips? Yeah, so the biggest tip that I can teach you, that I can tell you, is to make sure you understand the material well. They say the best way to understand the material is to teach it to others. And the other thing that I think really makes a good tutor or even a good teacher is patience. Because the people that are going to walk into your tutoring sessions need help, and they don't want how do I want to put this? They're gonna be asking a lot of questions of stuff that you already know. So that's the thing. Just be patient. All right, -1. Okay, so here I'm going to plug in -1 into my second derivative. So I have 0. So nope, not 0. Nope, no, not 0. So I have 6 times -1. Well, 6 times -1 is -6, and -6 is negative. So I'm going to put a negative here. That means on the interval from -infinity to 0, my function is going to be concave down. And then, let's pick a number greater than 0. Thank you, Xavier, for the follow. What math is this? This is calculus. All right, let's pick 1. So I have 6 times 1. 6 times 1 equals 6. And positive 6 is positive. So that is going to be positive. So that tells me from -infinity to 0, my function is going to be concave down. And from 0 to infinity, my function is going to be concave up. Thank you, Phil, for the follow. So that is going to be what we have to keep in mind. So now we can check that off. And finally, we have to look at the end behavior of our function. So what does that mean? Well, that means that as x goes to positive or negative infinity, what is y doing? So let's figure that out. So my function again, I'll write it up here, x cubed minus 12x. So as x approaches infinity, what is y going to do? Well, y is going to Thank you, Phil, for the follow. Yes, also going to approach infinity, right, because why? I have infinity cubed minus 12 times infinity. Now, what I usually do is I look at only the part of this function that has the highest power. So here, why? Because in cubing a number is going to make it grow faster than negative 12 times that number. So I'm going to ignore the negative 12x and just focus on this x cubed. As x approaches infinity, y is also going to approach infinity. And then, would y approach 0? Nope. That's if I had something like 1 over x. If I had something like this, then as x approaches infinity, y would also be infinity. So it is limit as x approaches infinity of y equals infinity. Yeah. So, your show is on. You're not dumb. I don't think you're dumb at all, David. Please don't think that. Thank you for the chili and the lightning bolt. So, then, as x approaches negative infinity, a negative number all cubed is still going to be negative. So this is going to approach negative infinity. Thank you, Steph, for the follow, and thank you, David, for the follow. Your show is on? Cubics unveil pitchfork bifurcations. So yeah. Let's go, and so now that we have everything that we need, let's go ahead and watch me attempt to draw this graph. Horribly, I'll add, but it'll be an attempt. So, I'm in Math 3 algebra, so I'm not at this level yet. That's okay. You will be one day. So here, I'm going to attempt miserably to draw this. Because as people who have been here for a while know, I can't draw. So we're going to see how we do. So I'm going to draw my line. There we go. Why is y approaching positive infinity? That's a good question. So here, as x approaches positive infinity, so when we look at end behavior, I'm only looking at the value of x with the highest exponent. So x cubed, so which is going to grow faster? A number being cubed or being multiplied by 12? Well, as x gets really large, it's going to be cubing a number. So I can essentially ignore this and only focus on x cubed. Now, any positive number cubed is going to return a positive number. For example, 2 cubed is 8, 4 cubed is 64, 6 cubed is 216. Either way, no matter what positive number I choose, my output will always be positive when I cube. So we can say that as x approaches positive infinity, as x gets really, really large, because remember, infinity is not actually a number. Infinity is just an idea. This is a way to describe the largest number. So as x approaches infinity, y approaches infinity. Same thing is true when x approaches negative infinity. No matter what negative number I choose, negative number all cubed is also going to return a negative number. So that's why as x approaches a really large number in the negative direction, y is going to approach negative infinity. Does that answer your question? And here comes the puzzle piece. Yeah, no problem. So again, now we're gonna watch me attempt to draw this. And again, no promises about this even being a good looking function. So what do we know? We know that its roots are at 0 and plus or minus 2 root 3. So 2 root 3 is approximately what? 3.4 something? Let me take a look. I don't actually know what the root of 12 is off the top of my head. So square root of 12 is 3.46. So it's a little before 3.5. So let me draw my point. So my x-intercept is going to be 1, 2, 3, about here. I have another one at 0. And I have another one at positive root 12. So 1, 2, 3, about here. And again, I'm just eyeballing where those are. Thank you for taking time out of your day. You're welcome, David. I'm always happy to do this. As long as people show up and say, hey, we're here, I'll always be happy to do this. Sup, man? How's it going? It's going good, Ryan. How about you? Learning the chain rule? That's really cool. That is really cool. So now we've marked where my x-intercepts are, and luckily our y-intercept is also at the origin, so I can take care of that. So now I need to know where my slope is positive or negative. So my slope is positive from negative infinity to negative 2, and from 2 to infinity. So from here on that way, my slope's going to be positive. From here on that way, my slope's going to be positive. And my slope is going to be negative at 0. And my max is going to be at negative 2. And my min's going to be at 2. So let me write that down. I seem to be running out of note cards. That's okay, because that just tells me I need to buy more. So, nope, don't want that one. Yeah, I think I may be out of note cards if I haven't or soon run out of them. Let me just use this. So f prime of x greater than 0, negative infinity to negative 2, 2 to infinity, f prime of x less than 0 at negative 2 to 2, max at x equals negative 2, min at x equals 2. And then, what else do we know? We know that we have a point of inflection at x equals 0. So, point or inflection at x equals 0. So that means the concavity is going to change from concave down to concave up. So concave down on the interval negative infinity to 0. Concave up from 0 to infinity. And then what else do we know? We know as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y also approaches negative infinity. So these are going to help me draw my function. So here we go. I'm going to try and follow all these rules. So we have negative infinity. So from here, I have this going on. So let's do that. So that satisfies the rule of, well, it actually doesn't really satisfy a rule right this second. But we have this going on. So at x equals 2, which is 1, 2 right here, I'm going to have that. And then concave down. All right, let me try that again. And again, this is an approximate sketch of the graph. I'm not, like I said at the beginning, I'm not very good at drawing. So we have a minimum there. And there we go. Let's see if that graph fits the criteria of all of these. So, is the slope increasing on this interval and this interval? So from negative infinity to negative 2, it looks like it is. And then from 2 to infinity, it looks like my slope is positive. So those two check. So we are good here. Is the slope decreasing from negative 2 to 2? It is indeed, so we can check that. We have a max at x equals negative 2. There it is, so check. Minimum at x equals 2. There it is, so check. We have a point of inflection at x equals 0. It looks like, so when we talk about concavity, we're talking about which way a function faces. So I have facing down, facing down, facing down, facing down, and here we go facing up. Yeah. So we have a point of inflection at x equals 0, so we can check that. It's concave down from negative infinity to 0. Looks like that's the case. Check. Concave up from 0 to infinity. Looks like we have that. Check. And finally, as x approaches 0, as x approaches infinity, y also approaches infinity. That seems to be true. So we will check. And finally, as x approaches negative infinity, y approaches negative infinity. So, yep, that appears to be the case. So check. So this satisfies all. So this is my best drawing of f of x is equal to x cubed minus 12x. It is a friction pen. It's the Friction Pilot erasable pen. And that is the pen that I am using tonight. Is this pre-calc? Nope, this is calculus. Oh wow, it almost took me an hour to do one problem. I don't think I've ever had that happen before. So this might be the final problem. We might only do 2 problems tonight, but that's okay. This is a bit involved, so that's okay. Any tips for compositions? Like fog? So if I have something like f of g of x. No, don't be sorry. Don't be sorry at all. Don't be sorry at all, Kion. That's perfectly fine. Hey, and you know what? We all start somewhere, right? Thank you, Susie, for the follow. I'm barely learning algebra, Chief. What I miss. So tonight we are just focusing on how to use calculus to sketch graphs of f of x. And actually, I think it was a good idea to split this up into 2 parts. So yeah. Thank you, Kion, for the follow. Have you made videos covering axioms for linear algebra? Not yet, but I'll be working on those soon. Can you show the chain rule? So I already did a live on the chain rule, and you can find that exact live here on this channel. So if you want them after this live, you can go there and you can go ahead and watch it. Yeah, no problem. I'm struggling with chain rule right now too. Okay. So remember chain rule. Let me go ahead and show you the rule quickly. So chain rule says, my derivative rules seem to be underneath my document camera. So if I have a function trapped inside another function, I take the derivative of the outer function and leave the inside alone, and then I multiply it by the derivative of the inside. Are you struggling with trig ones? Are you using them? Because if you are, I have my trig derivatives here too, if you want to take a photo of that quickly. Can you do a proof on the quotient rule using the definition of derivative? You know what? I actually said earlier that I was going to do a video proving all the derivative rules on my list, but I haven't actually gotten around to do that. So, I think I will. Thank you for reminding me, CTW. I almost forgot. Or I did forget for a little while. Thank you for reminding me. So, let's go ahead and do one more problem, and then we will go ahead and call it a night. Because tomorrow we're going to talk about how to graph derivative graphs from the graph of a original function. So there are 23 of us in here currently. Let's see if we can get to... Let's get to 4K likes. Let's see if we can't get to 4K likes before we get to the final problem. So hopefully everyone's having a good Tuesday evening, or in my case, Wednesday morning. If you're over here on the East Coast like me. I did see you in there, KG. Yay, math indeed. Yeah. Tell him I said hi, KG. Alright, we are at 4K likes. So now, let's go ahead and do one more. And then, we will call it a night. Let's do... Let's do this one. Y equals x cubed minus 9x squared plus 24x minus 10. Alright, so first, I should probably go ahead and find my x and y intercepts. So what I'm going to do is I'm actually not going to find my x intercepts here. Why? Because I don't quite know how to factor something like that. So instead, what I'm going to do is I'm going to go ahead and find my y-intercept. That I can figure out. So remember, y-intercept is found when I plug in 0 everywhere I see an x. So I have y equals 0 cubed minus 9 times 0 squared plus 24 times 0 minus 10. What's this from? So we're given a function, and we're going to be asked to sketch the graph. So if this is true, what must y equal? Charles says -10. Splash says -10. Yeah. So y is equal to -10. So the y-intercept is going to be at the point 0, -10. That's going to be very important for us when we draw the graph. Now, I'm going to go ahead and find where the slope is positive, negative, or 0. Nope, not using L'Hopital's because I'm not finding the limit. Thank you, Drew Ling, for the follow. So I'm going to take the derivative of that function. So dy dx is equal to what? What would the derivative equal? Flash says 3x squared minus 18x plus 24. Charles says x squared minus 18x plus 24. You're almost right, Charles. You're just missing something. What are you missing? Yes. Remember that Mohammed says 3x squared minus 18x plus 24. There you go, Charles. That's right. So take my exponent, move it out front, multiply by 1. X to the 3 minus 1 is 2. Thank you, CTW, for the follow. That's okay. That's okay, Charles. I'll be honest with you, I've done that many times, so I completely understand. Slow down, please. Okay. 2 times -9 gives me -18. X to 2 minus 1 is 1. And then 24, remember, variable without an exponent is the same as variable to the first. So 1 times 24 is 24. X to the 1 minus 1 is 0. And x to 0 is 1. So that is our derivative. Can you do a live for college algebra next? Like functions and relations. So it's actually funny because, yep, this is Calc 1. Because I have a live that's going to be dedicated to everything that comes before calculus. Thank you, Sharna, for the follow. So starting next week, we're going to be going live at 2 p.m. for anything before algebra, before calculus, and 10 p.m. for anything calculus and above. Thank you, Bull, for the follow. Why does x equal 0? Oh, here? It's equaling to 0 because we needed to find our y-intercept. Thank you, JM, for the follow. Would this help me in AP Pre-Calc? So what they're going to have you do, I actually don't know. It might. Can you do a trig derivative example? So tonight, because of how long these problems are, I'm only going to I'm going to do this one, but I do have other trig derivative videos. Can you go over limits? I know it's a lot, but I need a good way to remember them. Yeah, I think so too. But yeah. I have to like that AP Pre-Calc is relatively new, and I'm not as familiar with that curriculum as I probably should be. Or at least I don't have it committed to memory as much as I probably should. Anyone who's learning this, please master it. You'll need... I agree. I fully agree. Alright, so here, because I want to find slope, I need to start by finding the critical points. So what I'm going to do is I'm going to take this and I'm going to set it equal to 0. And I'm going to solve this trinomial. Do you see what I see? You're doing a form of this right now in Calc 30. That's cool. Do you see what I see here? GCF of 3. That's right, Jaden. So I can factor out a 3 out of all 3 of those terms. So I have 0 equals 3 times the following. Is this witchcraft? Nope. Not quite. So 3x squared divided by 3 is x squared. Negative 18x divided by 3 is negative 6x. And 24 divided by 3 is 8. So, since 3 can never equal 0, I'm just going to go ahead and divide that out. That way we can say bye to that 3. So I have 0 is equal to x squared minus 6x plus 8. There we go. I don't know why, but I need to adjust my camera, I think. So now, what two numbers multiply to 8 and add up to negative 6? Alexander says 4 and 2. Kevin says 4, 2. Splash says 2, 4. Right. Watch your signs, everyone. Because this is positive, but that is negative. That's right. So it's going to be x minus 4 and x minus 2. Now, does it matter which one goes first? No, it doesn't. It absolutely does not matter. So now I can use the zero product property to say either x minus 4 equals 0 or x minus 2 is equal to 0. Thank you, ... for the follow. So if x minus 4 is equal to 0, thank you, Morine Soul, for the follow. What math is this? This is calculus. A displacement graph's derivative is velocity, derived velocity for acceleration graph. Pretty cool to be. I agree. I fully agree. Let's use ChatGPT. Yeah. So ChatGPT sometimes gets these wrong. In fact, there are several times where it gets it wrong. So, if x minus 4 is equal to 0, then x equals 4. Or, if x minus 2 is equal to 0, then x equals 2. So those are my two critical points. So from here, I'm going to draw my number line, and I want to know which way my slopes are going to be going. So let's pick a number. Let's start by picking a number less than 2. May I recommend 0? Got a pre-calc test tomorrow, so I'm just going to fail. I'm just going to accept my fate. I don't think so, MG. Don't give up. Please don't give up. I have an exam tomorrow. Good luck, Charles. Yeah, lock in. You're gonna do great. 1 point. Oh my god. Do I teach related rates? Yeah, I already did a live on related rates. Please move forward with the problem. In a moment. I just want to make sure I catch up with the comments. I'm god awful at math, and this is the best lesson I've ever had. Algebra 1. Thank you, Rick Star. I'm really happy to hear that. I'm sorry to hear about your experience with math, but yeah, so alright, let's go ahead and move forward. So here, I'm gonna pick 0. So 0, so I could pick 1.99999, but it's gonna give me the same thing. And remember, I don't actually care about the value, I just care about the sign. So I have 0 squared minus 6 times 0 plus 8. 0 squared is 0. 6 times 0 is 0. 0 minus 0 is 0 plus 8 is 8. Thank you, Death, for the follow. So that's going to be positive. And then from 2 to 4, go ahead and pick a number. May I recommend 3? All right. So I have 3 squared minus 6 times 3 plus 8. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is negative 9 plus 8 is negative 1. Negative 1 is negative, so that will be negative. And now go ahead and pick a number between that's greater than 4. 5, all right? So I have 5 squared minus 6 times 5 plus 8. 5 squared is 25. 6 times 5 is 30. 25 minus 30 is negative 5. Negative 5 plus 8 is 3. Positive 3 is positive, so that is positive. So what's that going to tell me? That's going to tell me that the slope is increasing from negative infinity to 2 and from 4 to infinity, and that my slope is decreasing from 2 to 4. What are the random numbers for? So these are to tell us about what our slope is going to be at those specific points. So derivative tells the story of the slope. So at 0, my slope of the tangent line is 8. At 3, the slope is negative 1. And at 5, the slope is 3. So it helps us to figure out what the signs of my slope are, whether a function is increasing or decreasing. So you almost got it. You almost spelled it right. Here's the correct spelling of that word. There's an O right there, not an A. But other than that, you got it right. So now let's record that information. So far, what do we know? We know that y-intercept is at 0, negative 10. We also know that our slope is positive on the intervals from negative infinity to 2 and from 4 to infinity. And we also know that it's negative on the interval from 2 to 4. Thank you, Rick Star, for the follow. So now, thank you, Lisha, for the follow. What's the most important thing I should brush up on from Calc 1 for linear and differential equations? So linear algebra deals mostly with matrices. So I'm not necessarily sure you're going to be using much of Calc 1 and 2 for it. As for differential equations, it's in the name of the title. Make sure your derivatives are solid and your integration is solid. Thank you, Reina, for the follow. So now, let's figure out where our point of inflection is. To do that, I take the second derivative. So my first derivative, if you recall, is this. So, what would the second derivative be? So, remember, this is the second derivative, so I'm taking the derivative of my derivative. You missed calculus? All right. Well, here it is. Calculus is fun, I think. So what is the derivative of this? Yeah, I had to remember product rule for solving differential equations. Yep. You aced that quiz? That's awesome, Fat. That's really awesome. You know what that means, right? Do you know what that means, Fat? It means high five time. On three, we're gonna high five. Ready? 1, 2, 3. There we go. 6x Ham Chowder says 6x minus 18. Nope, you don't need to include your plus c. We're not taking the integral. No plus c. But you're absolutely right on your derivative. Take the 2, move it out front, multiply it by 3. 3 times 2 is 6. X to the 2 minus 1 is 1. And then the derivative of negative 18x, remember a variable without an exponent is the same as the variable raised to the first. So I take the 1, multiply it by negative 18 by moving it out front. And then I have negative 18x to the 1 minus 1, which is 0. And remember that x is 0 is equal to 1. So this is my second derivative. Oh, I forgot. 24 is a constant. Derivative of 24, because it's a constant, is 0. So now, I'm going to go ahead and set the second derivative equal to 0 to find my point of inflection. If that's true, what must x equal? I've literally brought people back from the dead, and this is way harder. I'm not sure about that. I think it's actually kind of cool. Julia says 3. Connor says 3. Yeah. Why is it 3? If I add 18 to both sides, so I have 18 equals 6x. Divide both sides by 6. So x is equal to 3. So that is my point of inflection. So let's write it down. Inflection at x equals 3. Now let's go ahead and find concavity. So remember, I'm going to do the same thing I did earlier with my critical points to find which way my function is facing. Go ahead and pick a number that's less than 3. Go ahead and pick a number. It is indeed. Okay, 1 works. So I have 6 times 1 minus 18. 6 times 1 is 6. 6 minus 18 is negative 12. So negative 12 is negative, so this means that my function is going to be concave down from negative infinity to 3. So let me write that down. So concave down on the interval from negative infinity to 3. And then pick a number greater than 3. 10? Okay. 6 times 10 minus 18. 6 times 10 is 60. 60 minus 18 is 42. 42 is positive, so that is positive, which means that my function is going to be concave up on the interval from 3 to infinity. So now, the last thing we have to do is think about our end behavior. So remember, here was our original function. So what can we say? So remember here, because we're dealing with end behavior, I'm going to get rid of everything that is not the highest power of x. So the only thing I'm going to be looking at here is this x cubed. So everything else we can forget about. So let me put a couple bottle caps over that to show that we're not going to worry about those. There we go. There we go. All right. So, as is it normal this stuff makes me want... I'm sorry, Isabella. I'm really sorry about that. Thank you, Doug Great Kali, for sharing the live. You have dyscalculia? Okay. Yeah, no, I completely understand. I have an undergrad calc exam on Friday. Will you be on live tomorrow? I will indeed. I will indeed. So here, if I take a positive number and cube it, I'm going to end up still with a positive number. So if I put in a really big number and cube it, I'm going to end up with an even bigger positive number. So we say that as x approaches infinity, y approaches infinity. And then if I plug in a negative number and cube it, am I going to end up with a positive or a negative number? For example, is that going to be a positive or negative number? You're welcome, man. I'd like to show my friends what I got to deal with. Yeah, that's exactly right, Julia. That's exactly right, Gravity kills. I'm going to end up with a negative number. So as x approaches negative infinity, y is also going to approach negative infinity. Because no matter what number I plug in, no matter what negative number I plug in here, that number all cubed is still going to be negative. So let's write that down. So as x approaches infinity, y is going to approach infinity. And as x approaches negative infinity, y approaches negative infinity. So now I'm going to go ahead and plug and try and graph this. Again, it's going to be a complete and utter failure because I can't draw, but here goes nothing. So, here is my best attempt using the information that we have to try and graph this. So now here comes the fun part. The fun part is watching me completely and utterly fail at this, right? Here we go. On your next live, would it be okay for me to give a problem for my practice exam? So normally during my lives, I like to focus on one topic at a time. But if you want, feel free to send me a DM me a question or two, and I'll be happy to answer those for you. So now let's take a look at my list. Hey man, thank you for all your help yesterday. I think I did well on my. That's awesome, Limon. You're most certainly welcome. I'm happy. I'm happy that you did well. You know what that means, right? Do you know what that means, Limon? High five. Oh yeah. Ready? On three. One, two, three. There we go. All right. So what do we know? We know that the y-intercept is at 0, negative 10. So I'm going to count down from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My intercept, let me try one more time. 1, 2, 3, 4, 5, 6, 7, 9, 10. So it's down here. I'm going to go ahead and check that off because I've already did that. F prime is positive from negative infinity to 2 and from 4 to 0. So, what do we know? What else? So we know that there's going to be a maximum here and there's going to be a minimum there. So, there's a point of inflection at x equals 3. So we're going to keep that point. It's going to be concave up from negative infinity to 3 and concave up from 3 to infinity. And as x approaches infinity, y approaches infinity. And as x approaches negative infinity, y equals negative infinity. Okay, here we go. Here we go. Are you ready? Because here goes nothing. So, have that. So concave down. Nope, that should be a point. That should be a max. Try that again. Point of inflection there. There we go. And there we go. All right. So have we met our conditions? F slope is increasing from negative infinity to 2 and from 4 to infinity. I have that, so check. My slope is decreasing from 2 to 4. Looks like that's the case. So so that's check. I have a point of inflection at x equals 3. Looks like I have one there, so I'll check that. But here's the proof. Is it concave down from negative infinity to 3? So we will check. So it's concave down, concave down, concave down. And here, yep. So that's checked. 3 to infinity, it's concave up. So it looks like it is. Yep. So that's checked. And now as x approaches infinity, y approaches infinity. Well, as x gets really big, we're climbing up to positive infinity, so that's checked. And then from as x approaches negative infinity, y approaches negative infinity. So down here, as I go closer and closer to negative infinity, I'm heading down, so that is good. So yeah. So this is my best drawing of f of x of y equals my function x cubed minus 9x squared plus 24x minus 10. Off subject, but can you help me with finding dy dx of 1 over the square root of sine 4x? So if you want, go ahead and send me a DM with that problem, and I'll be happy to help you there. So yeah, with that, I'm going to go ahead and call it a night. But before I do, I need to go ahead and plug some things. So first, I'm going to be downloading this live tonight and uploading it probably later on this morning. So to find this live and all my previous lives, you can go here and to this channel. And then here is the set of actions you should do when you get there. And then, if you want to follow me on TikTok, my account name is Robert the AP Math Guy. So you can follow me on TikTok at Robert the AP Math Guy. And speaking of TikTok, there are a couple other channels that I highly recommend that you follow. First, I recommend that you follow ACG Math Tutoring. She's really good at as getting people ready for the ASVAB, the Accuplacer, their GED, their TEAS test, or if you just need a general review of your algebra or geometry. She's a really good resource for that. And then, if you're interested in learning about the abacus, I recommend that you follow Learning with Lynette. I don't think she's live right now, but she's really good with the abacus. It's really a fun time, and if she does go live, this is where I'm going to be. So if she does go live, and you decide to jump in, tell her I sent you. And then I do online math tutoring. So I offer group tutoring, and I also offer one-on-one tutoring. If you're interested in group tutoring, I offer it to groups of 3 to 10 students per group who are all taking the same class at the same time. So it doesn't have to be with the same teacher or even at the same school. It just has to be the same class. So let's say you and 3 of your friends are all taking linear algebra. If that's the case, then you can all sign up for group tutoring. And for that, I charge $35 per hour per person for the 2025-2026 school year. And then I also offer one-on-one tutoring, but those rates are based on how often you want tutoring, how often you want to meet per week. And so, if you're interested in either one of these, feel free to DM me here on TikTok to schedule your free consultation. And then here is a list of every subject that I tutor. I'm struggling with linear algebra. Any tips? So how far are you along into the class? Is it still pretty early, or have you been going along? Early 2 months in. Okay. So the big thing that I recommend is making sure you have your algorithms in order. Because those algorithms are going to make a lot of those problems a lot easier to deal with. Remember your goal. The goal is to have a diagonal with all ones. If you got that, then everything else works itself out pretty well. And then, just like any other math class, I recommend that you ask questions to your professor if you don't understand something. And I also recommend that you work on spend like 20-30 minutes a night practice, because they say for every 1 hour of in-class instructional time, there's 2 to 3 hours of studying that needs to happen per week. So I don't know about you, but I think it's easier to spread out studying throughout the week in like 30, 45-minute spurts rather than one 4-hour session. But that's just me. But yeah. So, like I said, I'm going to go ahead and have this uploaded in about, I think it's going to take me about a couple hours. But yeah, so with that, I hope you all have a good rest of your evening. Tomorrow, we're going to talk about sketching derivative graphs when we're only given the graph of our original function. So with that, have a great rest of your evening, everyone, and I will see you all tomorrow at 11:30 p.m. Eastern. Bye, everyone.